In this question, we're trying to find out the value of R1, or in other words, the resistance of this resistor. Since we're dealing with resistance, let's write down Ohm's law, which is resistance equals voltage over current. Now for Ohm's law, whenever we have two quantities, we can calculate the third quantity. So we should look around at first to see if we can calculate that anywhere. Here we find we can do that because we have 100 ohms here, and we have 8 milliamps, or 0.008 amps. And that current has to be the same going through the ammeter as the resistor. That means we can find the voltage drop here. To calculate voltage, it's simply resistance times current. So here we have voltage equals 100 times 0.008, and that equals 0.8 volts. So each electron starts off with 2 volts, but we already lose 0.8 volts here. That means that we have 1.2 volts that span these 2 points. So if I had a voltmeter here, that would say 1.2 volts. So we have all of this voltage, but we don't have anything about current, but we do have some resistors here with their values given. And in fact, we can talk about this as one resistor that's equivalent to 600 ohms, because when the current comes into this junction, none go through this ammeter. We're told in the question that there are 0 amps going through this ammeter. So that means we have the same current going through this resistor as this one. It's all one complete path. So knowing that we have 600 as our resistor value, we have 600 is equal to, well, 1.2 volts is the potential across these 2 points. This point of wire is the same as this point of wire, likewise over here. So we can solve for now current. And if we do that, we get current is equal to 0.002 amps, 2 milliamps. So 8 milliamps came in and 2 milliamps went through the top part. That means, of course, that we have 0.006 amps going through this lower section. So that's good. We know how many, I'll write it as milliamps, we know how many milliamps are going through this resistor. But we don't know the voltage yet across this resistor. We know the voltage across 2 resistors. The next thing we can do is see that the voltage difference here is the exact same as the voltage difference here. And the reason that these 2 voltage differences are the same is because you can always move your finger on a wire, and if you don't go through a component, then there won't be a change in voltage drop. Now, we can pretend that ammeters have 0 resistance, so we can move our fingers through those, but we can't move across a resistor. So here, this voltage drop is the same as this voltage drop. Not the same as over here, because then I've gone through a resistor. So then I can calculate the voltage drop here, because I know it's 100 ohms, the resistor, and we know the current is 2 milliamps. So if I calculate that, I have my voltage drop is equal to resistance times current, which in this case is a 100 ohm resistor, and my current is 0.002, which gives me 0.2 volts. 0.2 volts for this resistor, that gives me 0.2 volts here. And since I now know my voltage and my current, then I can finish this problem. R1 is equal to the voltage 0.2 divided by the current 0.006, which if we calculate is 33.3 amps. Oops, not amps, what am I talking about? Ohms, which is answer A.